Go.
Okay, so we cut off last time, but we'll pick this up. Again, there's three ways that we're looking at here in calculating the torque from a single force. We can use RF sine phi, with positive or negative, and we can use plus or minus R perpendicular times F, and that's the lever arm. And so we see how the lever arm. It is the shortest distance, the perpendicular distance, from the axis of rotation. So when you get instructions like that, put your finger or pencil at the axis of rotation to the line of the force. Okay, so that's that. Now we're doing F perpendicular. So why are we doing that? Well, we can also calculate this as the torque from that force around an axis is plus or minus the magnitude of R, which we've already defined, times F perpendicular. So F perpendicular is the part of F. It's the component that goes around A. It's the part that twists or torques. It's not necessarily Fx or Fy. So when you're adding forces, you've got to break the forces into X and Y components. But here, the part that actually does the twisting, F perpendicular, is what gives you the torque. And so let's take a look at that, and then we'll quick review, and then on another video we'll do the examples. So if I've got, again, some rod, some axis here, and a force here, well, that force can be broken into two parts. The part that is, let's see, perpendicular to R, though, is the one that's going to rotate. So we need R. Let's draw R. We know what R is. It's from the axis of rotation to the point. Here's the line of R. And now F perpendicular is directed around. It's perpendicular to the line of R. So here's my line of R. F perpendicular would be, and this is a little tricky, would be right here. That's the component of F perpendicular to the line of R. However, where it's applied matters. And so think of it more over here. This is the part of F which is perpendicular to the line of R. That's the part that would rotate this object around point A. The other component would be here, and that simply goes into A and doesn't go around A. That does no contribution whatsoever to torquing here. This is what contributes to the torque. And so that's a good way to see it. Well, what part of that force is actually, if you want to twist, then push or pull this direction, and that'll twist or torque it. So that's the only part that matters. So in review, we've got R perpendicular to what? Perpendicular to the line of F. F perpendicular to the line of R. Either way will work. Phi is the angle between the line of R and the line of F. And so using that line of R and line of F can help you. These are different ways of seeing the same thing, and it develops a different intuition. So that's what we need to now explore in our next videos and examples. Okay.